The Paleogene is usually remembered as the beginning of the age of mammals. Yet in many ecosystems, reptiles still stood near the top of the food chain. In the warm landscapes of the Paleogene, reptiles had room to diversify in strange directions. Some still looked vaguely familiar, but grew into sizes and ecological roles that feel difficult to imagine today. Others went much further. Some hunted across dry land, others waited in rivers as ambush predators, and some followed evolutionary paths that left almost nothing comparable in the world today. The early Cenozoic was not a world moving neatly toward modern ecosystems. It was a period of ecological instability where reptiles, mammals, and countless other groups were all exploring new, evolutionary possibilities at the same time. One of the clearest signs of this reptile diversification was Boverisuchus, an Eocene crocodiliform belonging to the family Planocranidae. At first glance, the animal challenges nearly every expectation associated with a crocodilian relative. Rather than lurking motionless in rivers or swamps, it was a terrestrial predator built for life on land. Its limbs were long, its posture far more upright than that of modern crocodiles, and its teeth were laterally compressed and serrated, a condition known as xiphodont. These blade-like teeth closely resembled those of carnivorous theropod dinosaurs, a striking example of convergent evolution. Yet even these features may not have been the most unusual aspects of Boverisuchus. Fossil evidence suggests that its feet terminated in hoof-like unguals rather than the spreading claws typically associated with crocodilians. Imagine a crocodile running across the forest floor, not on sprawling feet, but on hoofed toes. Some researchers have even proposed that it may have been capable of briefly rearing onto its hind limbs while moving at speed. Whether or not it regularly adopted such a posture, the image is extraordinary. A crocodilian that behaved less like a modern crocodile and more like a predatory land animal, pursuing prey through dense Eocene forests. Its existence shows how some crocodiliforms moved into ecological roles once occupied by terrestrial predators after the disappearance of the dinosaurs. While crocodilians were exploring new lifestyles, lizards were diversifying in equally fascinating directions. One example was Glyptosaurus, a large anguin lizard that inhabited North America during the Eocene. Unlike some of its anguin relatives, it had relatively strong legs, and its body was covered by a dense mosaic of osteoderms that formed heavy bony armor. Modern alligator lizards provide a distant comparison, but Glyptosaurus carried this protective strategy to a far greater extreme. In a world populated by large predatory birds, mammals, snakes, and crocodilians, such armor likely offered a crucial defensive advantage. It stands as a reminder that the lizard radiation following the end-Cretaceous extinction was far richer and more varied than many people realize. In the great river systems of what is now Pakistan, reptile gigantism took a different form with Astogossuchus, one of the largest crocodilians known from the Cenozoic. Reaching perhaps 7 to 8 meters in length, it possessed a massive skull and immensely powerful jaws, capable of delivering devastating bites. Unlike the fleet-footed Boverisuchus, Astogossuchus was a true semi-aquatic crocodilian, more comparable in ecology to the Nile crocodile or saltwater crocodile, though likely even larger. Its world was populated by giants. Among them was Paraceratherium, the largest land mammal known to have existed. This enormous hornless rhinoceratoid could stand several meters tall at the shoulder and weigh many tons. Yet even such colossal herbivores were not entirely safe. Bite marks found on remains of young Paraceratherium suggest encounters with giant crocodilians lurking along riverbanks. The image is compelling. Some of the largest mammals ever to walk the earth, sharing waterways with one of the largest crocodilian predators of the Cenozoic. Farther across the tropics, Paleogene gigantism reached its most famous extreme. Around 60 million years ago, the tropical wetlands of northern South America were home to Titanoboa, one of the largest snakes ever discovered. Estimates suggest lengths exceeding 13 meters and a mass well over a metric ton. Closely related to modern boas and anacondas, Titanoboa was probably a semi-aquatic ambush predator capable of overpowering large vertebrates in rivers and swamps. Its enormous size offers more than a glimpse into the biology of giant snakes. It also serves as a natural thermometer for the ancient world. Ectothermic animals depend heavily on environmental temperatures, and sustaining a snake of such proportions would have required exceptionally warm conditions. Titanoboa therefore provides powerful evidence that Paleocene tropical ecosystems were hotter and more humid than any comparable modern environment. Among the many unusual reptiles that survived into the Paleogene, few are as enigmatic as Campsosaurus. For millions of years, this aquatic hunter patrolled the rivers and lakes of North America. Superficially, it resembled a modern gharial, with a long, narrow snout lined by slender teeth adapted for catching fish. Yet the resemblance is misleading. Campsosaurus was not a crocodilian at all, but a member of the Choristodera, a separate reptilian lineage that independently evolved a similar body plan. Even more remarkable, Choristodera survived the end-Cretaceous extinction and continued to thrive long after many other reptile groups had disappeared. For millions of years, they remained successful aquatic predators, representing one of the most enduring reptilian success stories of the early Cenozoic. In those same tropical systems, size was not limited to snakes. Carbonemys carried a shell that may have reached 1.8 meters in length, roughly comparable to the height of an average human. Its skull measured around 24 centimeters and housed exceptionally robust jaws capable of generating tremendous bite forces. Such a feeding apparatus suggests a highly opportunistic diet that may have included mollusks, young crocodilians, and carrion. Living alongside Titanoboa, Carbonemys occupied an ecosystem where gigantism seemed almost commonplace. Its immense size may have been partly driven by the intense predatory pressures of this environment. When enormous snakes and large crocodilians inhabit the same rivers, becoming larger oneself can be an effective defense. Combined with the warm and humid climate of Paleocene South America, these ecological conditions likely contributed to the evolution of one of the largest freshwater turtles ever known. The same region also shows that crocodiliforms were not following a single ecological path. Anthracosaucus belonged to the Dirosauridae, a group generally associated with marine environments. Unlike most of its relatives, however, Anthracosaucus appears to have adapted to inland freshwater systems. Its unusually broad and powerful snout suggests a more generalized feeding strategy than that of many dirosaurids. Rather than specializing on fish alone, it may have exploited a wide variety of prey. The animal illustrates how quickly crocodiliforms diversified after the end-Cretaceous extinction, repeatedly colonizing new habitats and ecological roles. reptiles also returned to the sea in forms very different from anything alive today. During the Eocene, the oceans were inhabited by Pterosphenus, a giant marine snake belonging to the extinct family Paleophiidae. Its vertebrae display distinctive adaptations, indicating a highly specialized style of aquatic locomotion. Unlike modern sea snakes, which evolved from elapid ancestors related to cobras, Pterosphenus represented an entirely separate invasion of marine environments. It demonstrates that the transition from land to sea occurred multiple times in snake evolution, producing radically different solutions to the challenges of ocean life. South America also produced one of the strangest turtles ever discovered. Neolamia, a member of the ancient Mealaniform lineage, possessed a skull adorned with prominent horn-like structures and elaborate bony projections. The result was an animal that looked almost mythical. Its head evokes comparisons to the horned frills of ceratopsian dinosaurs such as Triceratops, despite being separated from them by vast evolutionary distances. Such ornamentation is among the most extreme known in turtles and highlights how unusual southern hemisphere reptile faunas could become. If Boverisuchus represented one path toward terrestrial predation in the northern hemisphere, Sebacus represented another in the south. This South American cebacid descended from predatory Notosuchians, whose lineage survived the end-Cretaceous extinction. Over time, these survivors gave rise to formidable terrestrial hunters with deep skulls, long limbs, and serrated teeth adapted for slicing flesh. Ecologically, Sebacus occupied a role similar to that of large mammalian carnivores. In some respects, it echoed the predatory lifestyles once associated with certain dinosaurian hunters, illustrating how similar ecological opportunities can repeatedly generate comparable adaptations in unrelated groups. But the Paleogene was not only a story of giants. Cryptolacerta, an Eocene lizard from Germany, provides a fascinating glimpse into the origins of the worm lizards, the amphisbaenians. Modern amphisbaenians spend much of their lives underground, moving through soil with highly specialized skulls and elongated bodies. Cryptolacerta combines features of ordinary surface-dwelling lizards with traits associated with burrowing forms. It captures a transitional stage in the evolution of a completely different way of life and offers rare insight into how subterranean reptiles emerged. Europe's waterways hosted their own crocodilian specialists. Gigantism, an early Themistomine crocodilian related to the modern false gharial, possessed a long, narrow snout adapted for catching fish. Although less spectacular than some of its giant relatives, it occupies an important position in crocodilian evolution. As one of the earliest and least specialized members of its lineage, Gigantism helps paleontologists understand the origins of the long-snouted crocodilians that still survive today. Eocene, India adds one final giant to this world. Vasuki indicus, described in 2024 from the Eocene of India, may have reached lengths between 10 and 15 meters. It belonged to the extinct family Matsoidae and possessed an exceptionally robust body. Much like modern anacondas, it likely inhabited humid tropical environments where it preyed upon large vertebrates. Vasuki matters not only because of its size, but because of where it evolved. India during the early Eocene was still geographically isolated, functioning almost like a giant natural laboratory. Yet within this isolated setting, a lineage of snakes independently evolved gigantic proportions remarkably similar to those achieved by Titanoboa in South America. Two separate continents. two separate evolutionary journeys leading toward giant serpentine predators. In many ways, Vasuki can be viewed as the old world's answer to Titanoboa. The Paleogene was not simply a world where mammals rose and reptiles faded. It was a world where both stories unfolded at once. Mammals were expanding, but reptiles still hunted, swam, armored themselves, and reached gigantic sizes across land, rivers, and seas. The age of mammals had begun, but reptiles had not surrendered the stage.